All right, do we have audio this time? Yep, looks like we have audio. All right. So if we go and look in the notes here, or not the notes, but the daily announcements, you'll see some quizzes over in the quizzes tab of D2L. All they are is just placeholders for the MindTap ones. It'll make it real easy to find with due dates on them. I don't know why I made MindTap Quiz 2 due sooner than MindTap Quiz 1. Those need to be reversed. But anyways, so like if you went into it, what do we see there? It says, kind of wish that all the questions were just here, but I'm not going to type them all in. Otherwise, we wouldn't need MindTap. Read Chapter 1, look over the practice exercises, and take the Chapter 1 quiz, and come back here and mark true and submit the quiz. Right? So you just go there, take the quiz. It has to pop up 20 pop-up windows. So if you're getting error messages trying to access MindTap and it says your instructor must fix this, it's lying. You have to fix it by disabling pop-ups or using another browser. And I'm sorry for the difficulty. I wish it used cookies rather than pop-ups in order to manage its way around, but I guess people have so many cookie blockers that wouldn't be so good either. So anyways, your work in this activity will not be recorded until you complete all tasks and submit your work in the application. Now you have an infinite number of tries on it. Once you're done with your infinite number of tries, all you got to do is, not even that. Just take it once and then mark it true there. Once you've taken it once, it's kind of annoying to get back to, but we can find our way there.
You said you take these as many times as we want.
Right. But you only have to mark it as complete once inside D2L, right? That's just a due date kind of thing. So after you take the quiz here, come back here and mark it as done. You don't even have to do that. You'll still get the grade. But that way it'll be off your list of things to do. Only reason that we're putting those there is, one, to make them easy. And two, so if you log into D2L, you have some things over here, right? 2 quizzes not attempted are. Why is it? The way this is worded is dumb, right? 2 quizzes or available. Well, I guess that makes good sense English. But I would have worded it slightly different. Anyways, that's the only reason that those links are there. You don't even have to go in and take them. You don't get a grade for just marking that true or false. You get the grade for actually taking it. That makes sense? You don't have to keep coming back and doing these. Let's swap the due dates on these. I'll do that later. Not waste your time. While we're at it, let's go and look at the practice exercises there. See if there's anything we want to learn from that before we hit PowerPoints and stuff like that. So, as always, besides just accessing MindTap with its millions of different options there, there's something funky about the screen. It's on the edge considerably. See if we can do something about that without messing up the focus. Nope. Let's try that again. Nope. All right, I've used this room before and it wasn't that bad. All right, I guess I'll just resize my windows appropriate. Here's a different slider. Fool me. There we go. Of course, y'all might have liked the larger tags. What do y'all think? You like it like that and I just rearrange the windows? Or you like it like that so it all fits?
Like it so it fits.
All right. So like an eye exam. Like that or like what? Okay. We'll leave it like that until somebody complains.
That's good.
Hope it's focused. If you don't agree that it's focused, feel free to come up here and adjust the slider. My eyes are bad, so all right. All right, to get to the MindTap content, you can always just go into MindTap now that you're signed up for it. But if you click on Learning Resources, I said if you click on Learning Resources.
You're already on.
I'm on it already. Yeah, you're right. I'm already on it. There's download your data files and coding snippets. And here's something about getting started with MindTap. But then there are unit exercises. These are not worth grades. That doesn't mean they're not worth doing. Let's go take a look at Unit 1 exercises, see if there's anything we want to learn from it. Start assignment now. All right. I think we already looked at this. List the 3 common types of computing agents. And so on. Let's actually go and look at the quiz instead. And honestly, I'm not going to ask a lot of questions on the exam from these questions. But it's worth a grade, right? So you're going to want to take it a couple times, get a good grade on it anyways. Yeah. Which of the following are input devices? This is looking familiar. I think the speaker is not an input. Actually, you know what? Every single device you hook up to your computer nowadays is an input device because they do the, the communication and stuff like that. But we're not going to try to get all technical on them and get the questions wrong. Which are the outputs? Same with output. Half of y'all have, the fancy glowing lights on them that, can flicker and change colors, which makes it an output device. But we're going to go with a monitor and a digital cam. No. Why don't we just stick with monitor? What are the rules for forming sentences? Y'all tell me this.
Syntax.
Yeah, that's the syntax, right? You use syntax to create logic. I don't even know what they mean by pragmatics. Which of the following writes data, outputs data? That's pretty easy. All right, I'm feeling good about my quiz. I think I'm going to make a good grade. Y'all should too. Which of the following translates and executes instructions? That's the interpreter. If it just translated the statements without executing them, it would be a compiler. Right? I think we talked about that. A compiler makes an executable file that you can then send to somebody else and let them run it. But an interpreter translates them and interprets them on the fly. So it's slower, but more flexible. More flexible meaning that you can make that interpreter run on a variety of different platforms, and the same code will work on a variety of different platforms, Mac, Windows, Linux, your microwave oven, whatever. What's the purpose of the CPU? Receive inputs, send output, decode and execute instructions. That sounds a lot better. The CPU controls the rest of this stuff, but this is specifically what it does. And I think I drew Chip in the box and how he had, instructions to follow, so we're going to go with that one. Which of the following are general purpose computing devices? Well, a cell phone nowadays is a whole computer, but I guess when this was written, that can't really be true, right? My cell phone is probably more expensive and more capable than my laptop. But we're going to go with laptop. That's a general purpose computing device. A programmer thermostat is just a single purpose. A portable music player, pretty much single purpose. Nowadays nobody buys those. They use a phone. And it's like I said, cell phone is technically a general purpose computing, but I'm sure that that's what they really want. I hope that they're not trying to trick me. I should have read the chapter more carefully. All right, which of the following are series of examples? Examples of algorithms. I'm not digging that as an answer. That's not an algorithm. A dictionary is just a set of information, right? It's a whole bunch of words and their definitions, so that doesn't sound like an algorithm, which is a series of steps. A recipe, in my mind, is a series of steps. And a set of instructions for putting together a utility shed sounds like a series of steps as well. Which of the following contain information? All of them? Getting broadly, overly broad with the definition of information. Running computers have information. Audio CDs have information.
Smart fridge.
Yeah, you have a smart fridge, and you have, mayonnaise jars with expiration dates, but we're not going to check fridge. We don't want to outthink ourselves. My grandma's china cabinet, well, it probably has bicentennial plates with information on it, but I'm not going to check that. And a book. And what does idle do? It certainly does run Python. Does it do editing? Yeah, it saves programs to file. That pretty much means it's that. then it wrapped us back around to 1, so I'm going to submit. It says you will not be able to change the answers, but you can take it again. And I missed one. All right, review the test.
Great.
Wait, scroll up.
You missed
Yeah, it
number
says 8.
Oh, there we go. Thanks. All right.
Oh, one is spell checker too.
That's a program. That's not an algorithm. But, okay. If I took it again, I would certainly check spell checker in order to get the 100%.
Does it not change the question?
I can't take it right here and now, or I can't change it here. I have to retake it. Right, you have to start from the beginning.
If you took the test again, are all the questions the same?
Think so. We could find out. Try to take it one more time. They should be the same. They might be in different order. Yes, they're in a different order, same questions. So that's cool. And I've had people ask, why do you let me take the quiz over and over? And I think I said why, because the quiz is a learning tool in my mind, not a measurement tool. The exams are a measurement tool. I did have somebody try to argue with me that they should be able to take the exam over and over because I had said that they could take the quizzes over and over. Nah, most people understand that. All right, let's go look at the Unit 2. Not that we've lectured a lot on Unit 2, but I'm really interested in what their exercises are as well. So Unit 2 exercises.
Our exams, are they just questions, or are we going to do programs them with?
By and large, they're questions, right? There'll be 80% questions and then maybe 20% writing code. But if I ask you to write code, it's usually just like a statement or two. How do you write a while loop or a for loop or stuff like that? Not write a program that'll calculate the Fibonacci sequence, right? It's not going to be like 10 or 20 lines of code. The other thing that I might do, which I've done in the past, is find the syntax error in this code. And you go, oh, it's the missing colon or something like that, or it's not tabbed, something like that. All right, so I went to the practice exercises. All right, and again, this is stuff straight from the book. Useful stuff, but if you get tired of doing them, you can go to the quiz. Speaking of which, why don't we go and hit our PowerPoint again? All right, we've really covered editing, saving, and running a script, even though we haven't looked at it in the PowerPoints. And I think we pretty much understand this. We have a text file, which is our PY file. We hit the run button. The first thing it does is go through its syntax checker. Then it starts going into the translator, which generates a series of instructions which are run by the Python virtual machine. Just like an emulator for video games. This is what gets written for every operating system that supports Python. And you can have failures at the syntax error point. You can have failures as it's running. The failure as it's running could be like it can't open a file, or it's dividing by 0, or something like that. And this is the part that lets us type in and display information. We've talked about syntax errors a bunch. Unexpected indent. We've talked about how important indentation is. The only time you indent is if the line above it has a colon. If the line above it has a colon, there better be indentation after it. If you have indentation and no colon, not going to work. So, you will see that one a lot, perhaps, as you're writing code, just because it's easy to mess up. And I may mess it up here. you know, when you're doing a new file, and I don't even know which lecture we're on. Are we on D or E or
D.
D? Alrighty. I should just save them by date and then upload them to the correct file. But anyways, so put this in my favorite place. Yeah, we're on lecture D. See, it's easy to make a mistake here, especially if you've written in other programming languages, right? If A is equal to 10, tab, print wow, right? Looks good to me, not going to work. It's bad syntax. Well, for one thing, there's actually two errors here. And besides the bad tabbing, what else might be an error?
A is not declared.
Right, A is not even declared. It doesn't have a value yet, so how could you compare it? It's like saying, do you like my shirt? But I'm not wearing one. So, there we go. But invalid syntax. It did try to tell me what line the problem was on. Doesn't always work that way. I think I've mentioned that sometimes it highlights the line next to it or underneath it. Okay, invalid syntax. And then you'll stare at that for a long time going, what the heck, I don't understand why that's invalid. I know I wrote that print correctly. If you cannot figure out why a line is highlighted, then look on the line above it. All right, now let's get a different kind of error going. Let's get a runtime error. A is equal to 1 divided by 0. And it blows up. And you raise your hand and I come over and our program is 100 lines long and it's not easy to spot, right? Because it doesn't highlight runtime errors. Fortunately, it gives us the error. And if you're using a different editor like Notepad++, it's got line numbers down the side. And I wish this does too. But you can still figure out which line number it is, right? There's a little counter down here. Not the easiest thing to spot, but it says line 2. And here it told us that the problem was on line 4. So it's just a matter of moving the cursor up and down until I find line 4. And there's line 4. And I go, oh yeah, what do you know? It really is dividing by 0. So do use this line number information in conjunction with the error messages you see here. The syntax checker should show you the error messages right inside the editor, but the runtime errors will not. Instead, the runtime errors give you a line number. It'd be cool if this editor picked that information back up and went ahead and highlighted the line, and you'll see some programming editors, like C++ and Java editors, that do that, which is cool. And a summary. Let y'all read the summary. All right, onward, chapter 2. All right, software development, data types, and expressions. I'm going to skip a little bit of this because this isn't a software development class. Yeah, we're not becoming software engineers. You go to a 4-year college for that. Instead, we're learning scripting, dadgummit. So we don't need to know about customer requests, analysis, design, implementation, and stuff. Get the concepts, read the chapter, browse through the chapter, browse through the PowerPoint, but I don't need to say every single thing on every single PowerPoint for us to get a good education, and if I do that, we're not going to get very far. That's more fundamental stuff. You probably have already hit this in the last class, if you took the last class. True, programs rarely work as hoped the first time they are run, and then when you finally get them to work as hoped, you'll always see something to make it better. It's like there's some kind of saying, let's see if I can get it exactly. No program is ever finished, it's abandoned. right? Eventually, you get tired of making updates, to the software, and then you come out with version 2 of it, right? You come out with a different game rather than keeping updating, So, onward, maintenance takes up more time than analysis and design and implementation and integration all put together. This is saying that if you were doing professional software development, somebody, if not you, is going to be responsible for fixing bugs and adding new features to it. And in an environment where you're writing complicated software, then that's an expensive thing. You have to dedicate programmers to do that. You may have maintenance programmers. You may start off as a maintenance programmer and then move your way up into a program designer, right? Because it's kind of boring. No, it's not. It's not boring solving problems and actually coding. But you can get more responsibility, right, for actually creating what the program is supposed to do. And you can be sure that for a video game or Fortnite or whatever, there are some people who are in charge of designing the way it works. And then there are program managers. And then there are people who do the coding for the big stuff. And I shouldn't say the big stuff, because maintenance programming is also very important. And it's just that they're not breaking the new ground. They're fixing what's already out there. All right, now we're getting to good stuff. Text processing is by far the most common application of computing. Don't know about that, right? Video games, yeah, there's some text processing in them. But let's roll with it. Email, text messaging, web pages, word processing, social apps, all rely on and manipulate data consisting of strings of characters. Anything you type on the keyboard is a string. And if something else is going to happen to it, like it needs to have math on it or it needs to be saved, so that it can be done as a purchase order and written out to a database or whatever, that text is going to be manipulated somehow. So a data type consists of the set of values and a set of operations that can be performed on those values. Have I listed yet what I consider to be the 4 parts of a variable? This is more fundamentals again, but it's worth mentioning for 2 minutes. By the way, since this is just chock full of errors, I'm going to get rid of that. Every variable has a type, a name, a value, and a memory address that it points to. We don't care about that. Python doesn't let you figure out what the memory address is and access it directly. That's a more low-level thing that you would do in C++ and stuff like that, and it can be fraught with peril. In those programming languages, you have to have a very rigorous developing process in order to make sure you don't get what are known as pointer errors. But we care an awful lot about the type and the name and the value of it. So I'm going to put stars here. It's worth tucking away in your brain that everything is pointing to a memory address, right? Because otherwise, how is it saving data? It's not writing it on the back of an envelope. It's saving it in the computer to memory address. So there are lots of different types of data. We've seen ints or floats. We've seen numbers. We've seen strings. There are also Boolean, which are true-false values. I could do something like this if I wanted to. Am I hungry? Hungry equals true. In this language, you capitalize true and false. You still don't have it. Perfect. All right. Why do you have Boolean values? So later on, you can do an if statement or a while statement on them. If hungry, print, let's go eat. If you use a Boolean variable in that context where you set it and then later on there's a while or an if statement based on it, that's usually called a flag. We're flagging down the fact that we are hungry. It's just a term. So I'm going to add a comment here. Hungry is a Boolean variable, and you know this, which takes true or false values used in decisions later. And so called flags. Or I could say Boolean variables are called flags. I probably won't use that term much. I may say set a flag, and that just means that we're setting a variable to true. This is a stupid definition. A literal is the way a value of data type looks to a programmer. A literal is what's also known as an unnamed constant. This is a literal, right? That's not a variable, right? It's text, but it's hard-coded into the program. If somebody needs to go in and edit it, they're going to have to literally open the code and go change that, right? This is also literal. This is a literal. That's a literal. Literals are unnamed constants. They are things that are actually typed into the program. They are not variables. They get assigned to variables to do work. Again, that's more a computer science-y term. And then ints and floats are numeric data types. The integer data type in this language holds much larger values than the integer data type in, for example, Java or C++. We can see really huge values. If I do this, A is equal to, and I'm going to type in like trillion, which is 12 zeros. 1, 2, 3, whoopsie. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I don't know what the national debt is, but it's pretty large. Let's see if that works. And then if I print A, but I didn't do what I wanted it to do. Print A, pretty large. Let's check to see if it really is precise, right? If I change that and then print A, it's going to print it precisely. The integer data type in C and in Java, most implementations only hold numbers up to plus and minus 2 billion. And you can see that we're already in the trillions, and we could probably go up even higher. 1, 2, 3, 4, 5, 6. Just the way that the guy programmed it. He wanted a language where you could create really big numbers. That's pretty cool. So in those other languages, you usually worry about the minimum and the maximum data type, or size of data, right? The size of the number that you can store in it. In this language, it's usually not a problem. You can store really, really large pieces of data in it. And I just said this. Literals are numbers. Here's some floating point literals. Here's some string literals. Two apostrophes or two double quotes is known as the empty string. You can set an empty string and then you can add something to it. Like if I do this. Name equals, there, that's an empty string. There's nothing in it. If I print it out, it would print out a blank line. But I can add something to it, which is known as concatenation. I would probably use the word append, since I like speaking English. But name plus equals Joe. There. I've concatenated, which means appending, or more colloquially, adding to, right? I added the word Joe to my empty string. Let's say I want to tack on another name. How am I going to separate it? Am I going to separate it by spaces? Am I going to separate it by commas? So name plus equals a comma followed by Jack. End quote. If I hadn't put this comma in this space there, then when I printed it out, it would say Joe Jack with no spaces. Let's prove that. It looks good at this point. Print out the name. Something funny that this language does, it's a laugh riot, that other languages don't do is, watch this. We have a name variable, right? Print out name times 10. Print out name times 1,000. All right, why is that useful? It's not useful for that context, but if you need to print out a line of dashes or a line of asterisks or something, you can say I want 70 dashes, right? And boom, it comes out like that. And that's really pretty neat. I've never seen another language that does that. So, the string data type, the data type dictates what kind of data it can hold and the operations that can act on it. So data type dictates what kind of data the variable can hold or can be stored, and the operations that can be done. So for strings, we've seen two operators. There's really a third one because a lot of people count the equal sign as an operator, right? You're copying something to something else. But so for strings, you've just seen the addition operator and then the multiplication operator. I'm not so fond of saying that the multiplication operator is an operator because that makes it sound like we can do math on it. And I'm not fond of the term addition because it's not really addition, right? So it's the plus sign, which does concatenating, and I can't even think of a good name for what the multiplication symbol is, we could call it. We could look it up or something. Multiple concats. Numbers have a lot more operators, right? Addition, subtraction, multiplication, division. Addition, subtraction, multiplication, division, and then the power of, exponent, and then floor division. And then lastly, can anybody remember the last one? If you do floor division, it rounds down to a whole number, like 5. Floor division 2 is 2, but then there's something left over. And if you care about getting what's left over, what's that called? Modulus, exactly. I should just do a triple quote, because since I'm typing notes, I'm having to prefix everything with hashes. So I'm going to do that. Of course, then I'll probably only type one more line of... Anyways, so triple quotes opens a multi-line comment, or a multi-line string, does the same thing. So we know what 5 plus 2 is, 5 minus 2. Let's do 5 to the power of 2. What is that? That's 5 squared, which is 25. 5 divided by 2 is 2.5. 5 floor division 2 rounds down, because floor division rounds down. And then 5 modulus 2 gets the remainder, which is not 0.5, right? The remainder is 1. So 8 modulus 4. Well, 8 divided by 4 is what? 2 with a remainder of 0. So 9 modulus 4 is 2 with a remainder of 1. Exactly. 10 modulus 4 is 2 with a remainder of 2. And 11 modulus 4 is 2 with a power of remainder of 3, and then finally we get to the next whole one. That's good, right? 12 divided by 4 goes in evenly, right? So remainder of 0. 12 divided by 4 is 3 with a remainder of 0. And why do you care about that? Well, what if you had a number of pennies and you wanted to convert that to dollars and cents? I'm going to close my multi-line comment, and then I'm going to type in pennies equals something, right? pennies equals 9,876. Now, our eyeballs, we know our money system well enough to know that we could turn that into dollars and cents just by putting a point there, right? $98.76. So dollars technically is equal to pennies floor division 100 because there's 100 cents in a dollar. And then cents is equal to the remainder. So pennies modulus 100. And if we printed that out, we would get $98.76. So print. I'm going to do it in a really fancy way. Percent D for an integer number. Let's put a dollar sign in front of it. Dollar sign percent D. And then a period because that's how we express our dollars and cents, right? That period's going to kind of make it look funky considering what's coming up next. And then percent dot 2. I'm not liking where this is going. I'm not sure that that's strictly true. Let's see if this works. Percent 2f, meaning it's supposed to print out 2 zeros, you know, if it's value of 0. I'm not totally sure this is correct, and if so, then I took us up a wild goose chase. But I want to show you the syntax anyways. Tell you what, I'm going to get rid of that period. It looks suspicious. I'm even going to get rid of the dollar sign. I just want to see what this looks like. I'm hoping that I will see like a 76, which is 2 places, but if I change that to a 0, 0, I want to see 0, 0. I want to see 2 zeros, because if we did put a dot there, it would look like dollars and cents. So this is a formatted print statement. There are other ways of doing formatted print statements as well. This is the way that I do it because it looks like what you can do in Java and C and C++. However, I should switch over to doing the dot format because pro Python programmers like doing the dot format. But let's go with the one your teacher knows because I'm more likely to get it right. The syntax is we put a percent sign after our string, and it doesn't mean modulus in this case. It means that whatever we put in here is going to fill in these placeholders. So I'm going to pass in the dollars, comma, and then the cents. And I really think it's supposed to be percent %D, percent %2D. So that's what I'm going to try. Well, it worked for that, but that's because this already was 2 digits, right? So let's see what happens if this is a 0, 1. I want to see whether it just prints 1 or 0, 1. That's really what I want it to do, and if it doesn't come out right, I'm not going to spend too much time figuring it out, as in no time. It didn't work, but it did space it out, right? Because we have those 2 digits there, and then we have that space, which was a period until I changed it. And then we have 2 spaces. What this is saying, like if we put a 10 here, and then we put a 10 here, is make this number occupy 10 spaces. Pad it out with spaces. So both of these are going to be 10 spaces wide. And I think I'll just put a comma here, putting something back in there so that when we print it out, we can see where the spaces begin. Right? So this is 10 spaces, and this is 10 spaces. We're going to see a lot more of the percent formatting. Why do you care? Because you could create nice looking tables. Right. What if the first number we're printing only has 1, and the next one we're printing has 5 digits, and the next one has 4? We like them to be lined up, right? Like in an Excel spreadsheet or something like that. We don't like the data to be ragged. I'll give you an example of ragged data. No, I won't. Let's go on. We can always come back. So what triple quotes really means is that we're starting you could call it a paragraph indicator. It just goes all the way to the next line. If I did this, story is equal to, and then I went to Walmart to get eggs. That's not going to work. That's going to be a syntax error. If I run it, we'll see that to be true. Because a single quote cannot span 2 lines. It cannot span multiple lines. However, multiple quotes can. 3 of those. And then when I print out the story, it would look just like that. Going back to modulus for a second more. What if we have ounces? Going from ounces to pounds, I think there's 16 ounces in a pound. So say I have 100 ounces. Well, pounds is equal to 100 floor division 16. And then the remainder of the ounces is equal to, wait. Pounds is equal to ounces because we want to use this variable. So ounces equal to 100. Pounds is equal to ounces, floor division 16. That gets us the whole number. And then ounces is equal to ounces modulus 16. That gives us the remaining ounces. And I don't know how many pounds and ounces are in 100 ounces, but I'm going to find out soon. Print pounds, comma, ounces. Right, I'm not going to make this one fancy. I mentioned the fancy formatted printing, but I'm not going to spend any time. Okay, and so 100 ounces is 6 pounds, 4 ounces. Hope that makes sense. You can convert from one unit to another and get the remainder of it by doing that. On the other hand, if it's okay to say 6.25 ounces, then that would be fine. We could just print out ounces is equal to 100, pounds is equal to ounces divided by 16, not rounding down. Whoops, that was supposed to be an equal sign. Forgive me. And then when we print that out, that's what we're going to get. We're going to get 6.25, I believe. Because 6 pounds, 4 ounces is equal to 6.25 pounds. When I ask you to do conversion problems, right, convert pounds to kilograms or whatever, just do it in that format. You don't have to do floor division and modulus to piece it together unless I very specifically ask for that, and I'm not planning on it. But I'm giving you several examples because I want you to remember what percent means and what slash means. Anybody have syntax errors that you really wish would go away? Okay. That almost sounded like you got one. Let me come look.
I'm just wondering if it's the same idea.
Yep. You're not supposed to indent if statements. You never do an indentation if there's not a colon on the line above it.
Yeah, I had it like this originally.
Let's see what it does. What does that say?
Oh, that's why. Easy to manual to unexpected in there.
Line 5. There isn't a. Well, go up to that line and see if there's a space in front of the A.
penny, so it'd be down.
Yeah, that's what I was wondering.
It's just only like 50 something. Might just say it's errors.
That seems like a spurious error.
52.
52, okay.
So it just wasn't big enough.
Yeah. I'm sure not seeing. Well, scroll up, see if there's.
Exactly like, one exactly like, yeah, errors actually at 151, it's just one beginning 52. It's trying to block all this in together, that's that too.
It should be okay.
There's a line beginning of line 52 in the middle.
Yeah, I like that idea.
Yeah,
Yeah. this is, I'm not sure, you saved it first, I think I see an asterisk. Yeah,
That's where it was.
Okay, okay.
That's why we're blocking all those together, just catching it. I think.
All right, guys, it could be sneaky. If you have a whole bunch of,
So you have to backspace.
all right, guys, I want to talk now. My turn. This could be sneaky. If you have a whole bunch of stuff up here like that, it could all be spaced over like that. Looks good. But then when your code comes in, it doesn't look wrong. And then it runs, and it does say unexpected indent. Now, at least this is making it real clear because we're using idle. But if you're using another editor, it'll give you a line number and tell you unexpected indent, and you can spend some considerable time going, that's not an unexpected indent, because it would just show it to you as white space. Escape sequences. Escape sequence is why is it called an escape sequence? Because it changes. It's some term that somebody made up in the 60s or something like that. If you have a string that looks like this, S equals 1 backslash N 2 backslash T 3, and then you tell it to print, parentheses S, it's going to print out 1, but then it's going to get out of the printing mode temporarily. It's going to escape the normal string processing mode and translate that as a very special symbol, meaning line feed. So it's going to go to the next line. So it's going to print a 1, then it's going to go to the next line, and it's going to print a 2, and that's a tab, and it's going to print a 3. Like that. Backspace is a strange one. S equals hello backslash backspace backslash B backslash B backslash B backslash B I, and it's not going to print out hello, it's going to print out hi, because I backspaced 4 times. That may have been real useful back when you had like typewriter output, right? Because you could type a word and then you could backspace over the word and you could use the underline, and that would underline, you know, on a modern screen. Doesn't do anything we want. Well, what do you know? That's kind of dumb. Forget the backslash B. I'm not even sure why it's mentioned.
Mine printed out, it just counted the number of backslash, went back to the E, backspace the E, and replaced it with the I.
So it worked for you. Why didn't it work for me? Don't know. Glad to hear it worked for you. Otherwise, it'd be really stupid to put in the slide. If anybody else typed it, did it work, or did it put the 4 dots?
4 dots. 4 dots.
I'm also going through Notepad++.
Okay. So you're running it through a real. You're running it in the Python shell rather than the idle shell. That's interesting. The idle shell should be the Python shell. There should be no difference. But this is the first time I've seen a difference.
Well, Notepad++, when you run, it runs in a command prompt.
Right. But until now, I would have thought that this was an exact mirror of what you see in the command prompt. First time I've seen it different. All right, a couple more escape sequences. S equals C colon backslash new dir, like that, and then print out S, and you're not going to like the results. It prints out C colon, goes in the next line, and prints ew dir. I don't want my directory to say ew. I have to fix this by convincing it that that really is a backslash and not an escape sequence. So you do that by doing 2 of those. The first backslash says, this is an escape sequence. I want to print something different. And then the second one is just, oh, I'm kidding. I do want you to print a backslash. Now it's going to look good. Similarly, that sounded wrong. I don't think I said that right. There is backslash single quote and backslash double quote. And why would you need those? S is equal to I love, quote, eggs, end quote, and another end quote. You can kind of tell by the coloring that this is bad news, that this is not going to work. Now, y'all have all seen, handwritten signs where people put quotes around, a word to indicate that it's an important word. That's not what the quotes around a word means. But say that I wanted it to do that, I have to convince it that this is not the end of the string. It is something I want to print. So I turn these into escape sequences with more backslashes. Now when I print it out, it's going to print out good. Print out I didn't print it out, so can't prove that. Next line. Print S. All right. And then it prints out I love eggs. Hope that makes sense. If I want a double quote to appear in my output and the string is declared with double quotes, I would need to do that. Now the funny thing about this language, which is not true for other languages, is that you can get away with not having to do that if you use single quotes. S is equal to single quote. I love eggs with double quotes there, and then another single quote at the end. Why? Because we're not in the middle of a string that was declared with double quotes, so when we hit this one, it's not a problem. You'll see this in JavaScript as well. So if you don't feel like putting escape sequences to fix the use of double quotes in a string, just declare your string with a single quote because they are interchangeable in this language. You can use single quotes to mark a string or you can use double quotes to mark a string. I tend to almost invariably use double quotes because that's how it's done in the vast majority of languages I've used. Java, C++. Just to prove that works, I'm going to print S again. There we go. If you need a single quote, you could put a backslash single quote, backslash apostrophe. Not going to bother. Yeah, why not? I'm going to copy those two lines. Copy, paste them, replace these with single quotes, with apostrophes. And again, we can see that we're building up to a syntax error, right? Because it changed. This is no longer part of the string. I want it to be part of the string. I put a backslash in front of those apostrophes. And now it's all a good string again. Syntax errors going on over here.
No, I was just wondering about his.
Some people are too shy.
Yeah. What I do is I count the number of backspaces, like 1, 2, 3, 4, backspace over that character. That's what
I see a red line here.
That's what it's supposed to do, it just didn't feel right.
There's no line there. Perfect. Has it been broken the entire time? Didn't ask for help. Ask for help. Go ahead and run it. It ought to be fixed now. Now I can't see that one. What's wrong with this? I think there's just a missing equal sign, maybe? No equal sign in front of pounds. Or after pounds. So putting backslash after the word eggs. You've got a backslash before, but you need more after.
You can't
as well.
Yeah, because you highlight it, and I've got this Control-Shift Q.
In the middle. Get rid of this one.
I wish it kept showing them all, just the first one. And then division by 0. So, it's just like, did I change that divide by 0 in order to fix But it tells us
Like,
line
some
number,
stuff it's cool.
line number 6, to scroll all the way up to the
When
top
you're
and
just
just comment
like
that
this,
line
the
out.
slash B,
This one?
trying to do
Yeah,
that.
just
You can make
It
it
won't let you.
I think
Yeah,
I'll
so
go
it's
through
gonna
it.
go first.
Yeah, it's like, if you like type in
Or not.
text.
True, true and false have to be capitalized in this illustration, so make that a capital T, not the whole word, just the first name. All right. Well, make sure you got a capital T there, your eyes are better than mine. Yep, got it.
Christ in the world.
All right, cool. Do ask, right, right.
What is
That I'm not sure.
So this slide is telling us that you can do concatenation, which we've already hit. Hi plus there plus kin. Now, unless you actually put a space there, then it would say hi there with no space. And then, like I said, you can create a long string. I showed you by putting the number first, right? I did 10 times something. But yeah, if you want to create 10 spaces in a row, then you could do that. 10 times quote space quote. And also, if you wanted to print out the word Python 10 times in a row, which would be stupid, you could do that. Right, and then it's going to print 10 spaces, and then it's going to print the word Python 10 times.
So it's easier just to use comments.
So a variable associates a name with a value. It's a name placed in memory that can hold a value. Why do you do that? So you can remember it and use it later in the program. There are times when you could get away without creating a variable, right? Like if I happen to know the tax rate in Midwest City is 7.5, then I could say tax is equal to, whatever my purchase is, 90, and I don't know if it's 7.25, lost track of it, times 0.75, that's our tax rate, our pretend tax rate, and then we could print that out. But that's not a very good solution because it's assuming that our purchase is always $90 and that the tax rate is always 75. I got that wrong. It's 0.075. That's 7.5%. Anyways, it's assuming that our tax rate never changes and our purchase never changes. These are, again, what are known as hard-coded values. Another term for them is magic numbers. If somebody was looking through here, well, what in the world is 90? What is 0.75? Magic numbers are literals that are coded into the program that should be stored in variables so that they could be changed. So 90 should not be that. It should be purchase, right? Purchase equals 90, and then I replace this 90 with purchase so that it could change. I could ask the user for the purchase. And then the tax rate. Now, if it's a number that's never going to change, like they're always exactly 2.54 centimeters in an inch, it's probably okay to use 2.54. But tax rates do change, and they do differ on a municipality index. So I'm going to say tax rate equals 0.075. And so my tax is going to equal a purchase times the tax rate. Now I'm good to go. Now if I needed to change the purchase amount or to ask the user what the purchase was or look up a tax rate based on a table, or read it from a file or something like that, it's easy to do. I could have these even declared way up at the top of the program. Sometimes you see people do this. They take these things and they move them way up to the top of the program. Then there are the idea of constants versus non-constants, right? Your purchase is probably going to differ every time you make a purchase. The tax rate you may think of as a fixed number. It's not going to change, right? You're not at 7-Eleven and some things are taxed and other things are. I'm not strictly sure if that's true with, like food stamps and stuff like that. Maybe they're not taxed, I don't know. But things like the speed of light is not supposed to change. So, if I did this, speed, I'm going to use underscores, of light equals, I forget what it is, speed of light in meters per second. All right, 2 times 10 to the 8. Can I type in stuff in that format? Can I use T to e to the 8? And was it really 2 or was it 3? It's 3. Yeah, or 2.998. Okay, let's get it all precise. 2.998 e to the 8. And then later on, I calculate something. The famous equation, E equals mc squared. The c is the speed of light, and the m is matter, and the E is the energy produced. So, if you have a nuclear bomb, it's turning a very small amount of matter into a huge amount of energy because it's multiplying it by the speed of light squared, which is a large number, right? And so squaring it would be even larger. That's why nuclear bombs are so, so big of a kaboom. But, so in that case, though, the speed of light is not supposed to change in my program. It should be a constant. In this language, there is no way you could mark that as a constant. And constant meaning that the value doesn't change, that it cannot change, that it would get an error. The way people distinguish constants versus non-constants in this language is just a gentleman's agreement that if the variable name is all caps, it's a constant. So, if we're saying that the tax rate is a universal constant that should never change throughout the program, we should put it in caps. Am I going to count you off if you don't do this? No, but if you're looking at code and you see a variable name written in caps, it means that you're not supposed to change it. And if you try to change it in some languages, it'll actually generate a runtime or a syntax error. Not in this language. Constant should be in caps. Variable names in caps represent, like I said, via gentleman's agreement, it's not enforced by the compiler, values that should not be changed. So later on in the code, I should not change the speed of light, right? And I probably know that, but maybe I don't. But if I saw the variable name declared in all caps, I would not change it. So if I see something that says this, dir is equal to, I'm going to use a single quote here, C colon, no I'm not, double quote, C colon backslash new dir in backslash. I'm going to, looks like dir is a keyword, right? It's in purple. So I'm going to change this. File name equals C colon backslash new dir backslash t.txt, something like that, right? If this is in lowercase and I'm editing this program, I may think that later on it's okay to give myself a new file name, right? I might be able to do file name is equal to something else. But if I see this file name in caps, I'm going to know that it has a very specific meaning and I should not change it later on down in the code. Now maybe you need to change it as a constant, right? Maybe the speed of light, maybe 2.998 isn't precise enough. Maybe it's actually got some, 0.001s later. Well, then go ahead and edit that constant if you need to make your code more precise. Or if somebody tells you, no, I don't want to save the file into that new dir, I want the file name to be something else. Well, then it would be okay to edit your code and change the file name to something else. But during the editing of the program, if you're using file name in one place and then you use it somewhere else, you should not change its value in the interim. It should always be the same from the beginning to the end of the program. And that's what the all caps means. In those other languages, you tell the compiler that it's a constant by adding that keyword, or in some languages that you use that keyword. Meaning, this is my final answer. That variable is not supposed to be changed through the rest of the code. But we don't have those keywords. Almost time to wrap up the class. So, we have one homework assignment. Time to give y'all another. Can't let you get bored. Oh. By the way, I want to mention that if you can't get Python to install on your home computer, and for that first one, it said, install Python, tell me. If you can't install Python, then tell me you can't do that, and then you're going to either do your homework here, or you can do it online, with an online version of Python. I'm just going to type in online Python in Google and hit the first one, and it takes me to a perfectly valid version of Python. Right. And then I can run that. Why did I have to accept that agreement and then it took me away from the page? Well, once I've said it, maybe it's okay. All right. So there, I could write my program here, right? I could say x is equal to 10, print x, whatever, and it's going to work just fine. I see my results over here. You better save that, right? If you're going to submit this as a PY script, if you're going to put it in the Dropbox, you better save this. Otherwise, as soon as you close the window, it's gone forever. But you can write Python code online in one of these online Pythons, right? The first one worked great, online Python. The second one may work even better. I don't know. Well, why is that taking so long? Anyways, okay, here's another one. You don't like that first one? You try this one. You can find one that you like. Just remember that you better save your code. You better open up a notepad is a perfectly good way. Or even opening up Word. I would not recommend using Word. But you could do Notepad. You could type in your code there. Well, I didn't copy it. Thought I did. Control C. Control V. Well, that's looking pretty lousy.
Format word rep.
Yeah. I don't think that's the only problem. It was. All right. Cool. Okay, so anyways, yeah, turn word wrap on if you don't have word wrap on. And then save it as a PY file. Homework1.py. Then take a screenshot, right? And it proves that it worked. That makes sense? I'll put a link, but you can always get to one just in 2 steps, right? Google, well, maybe 3 steps. Online, Python, and go there. All right, lastly, homework. This is not going to take a long time. Write a script that will print out a verse from a song, or a poem, or a speech, or just something you want to say, right? I love Python and I'm so glad I am in your class, right? Just make sure it spans multiple lines. But you don't have to go nuts and type in like, 2,000 lines of Eminem's Rap God song, right? Just, 4 lines or whatever. But I want you to do it 2 ways. One with print statements, 1 per line, and then one with a single print statement with a multi-line string. How do you do a multi-line string? You use 3 quotes rather than 1. So, those are your 2 methods. Multiple print statements, 1 per line, and a single print statement with a multi-line string. I'll even give you a hint. Triple quotes. Right, like that. Pretty short assignment. You could knock that out in 5 minutes, most likely. If you get stuck, ask me for help. We got to make that a little bit harder. Print out your whole name with each word separated by tabs, which is the \T character. And then, lastly, print out your whole name with each word separated by new lines, which is \N. And then upload the PY and a screenshot. And when I create a homework assignment, I upload it in the notes and I upload it in the homework file directory. But It's also cool if you type it in your notes. You just don't have to. In my multi-line string with 3 quotes, we should be done. Any questions? This will be due a week from today, so it'll be due Monday at midnight with a day's grace period. We all good? You don't have to upload screenshots for your daily work, right? Whatever we typed in class today, it's just too much extra time to take screenshots of that. And what you upload during the daily lectures, it doesn't even have to work. And if you don't type in notes at all, just upload a note saying that you were here. All righty, I think we're done.